The outer reaches of our solar system beyond Neptune are shrouded in mystery, largely unexplored and only recently understood. Two fascinating regions, the Kuiper Belt and the Oort Cloud, hold some of the most primitive and ancient objects in the solar system. These areas give us clues about its formation, influence cometary activity, and play crucial roles in understanding both planetary dynamics and cosmic evolution. This video takes a deep dive into these regions, what they are, their composition, and their impact on the solar system. The Kuiper Belt is a vast, donut-shaped region of space extending from just beyond Neptune's orbit, roughly 30 astronomical units from the Sun, to about 50 astronomical units. It is populated by millions of icy bodies, including dwarf planets, comets, and planetesimals, remnants from the early solar system. Composition of the Kuiper Belt. The Kuiper Belt is home to objects made mostly of ices, including methane, ammonia, and water ice. Some of the most well-known Kuiper Belt objects, KBOs, include Pluto, Haumea, Makemake, and Eris, all classified as dwarf planets due to their size and characteristics. Pluto, once considered the ninth planet, Pluto is now the most famous KBO. With its 5 moons, including Charon, Pluto is composed mostly of rock and ice. Haumea, known for its elongated shape, Haumea has a rapid rotation and a ring system, which makes it unique. Eris. Eris is even more massive than Pluto and sparked debates leading to Pluto's reclassification as a dwarf planet in 2006. How the Kuiper Belt was discovered. The existence of the Kuiper Belt was first theorized in the 1950s by Dutch astronomer Gerard Kuiper, but it wasn't until the 1990s that actual KBOs were observed. The discovery of the Kuiper Belt marked a turning point in our understanding of the solar system structure. We now know that this region likely holds the key to understanding how planets formed and how the solar system evolved. Role in the solar system. The Kuiper Belt is often compared to the asteroid belt, but on a much grander scale. One of its major impacts on the solar system is through the formation of short-period comets, comets that take less than 200 years to orbit the Sun. When KBOs are disturbed by the gravitational influence of the outer planets, particularly Neptune, some are knocked inward, becoming comets visible from Earth. For example, Halley's Comet, which visits Earth every 76 years, is thought to have originated in the Kuiper Belt. While the Kuiper Belt is relatively close, the Oort Cloud exists at the extreme limits of the Sun's gravitational influence, ranging from 2,000 astronomical units to 100,000 astronomical units, about 0.5 to 2 light-years away. The Oort Cloud forms a vast, spherical shell of icy objects surrounding the solar system and is much more difficult to study due to its immense distance. What is the Oort Cloud made of? The Oort Cloud consists of trillions of icy bodies, ranging in size from pebbles to objects tens of kilometers wide. These objects are composed mainly of frozen water, methane, and ammonia. Unlike the relatively flat Kuiper Belt, the Oort Cloud is a three-dimensional sphere that envelopes the solar system, potentially acting as a reservoir for comets that journey inward. Long-period comets and the Oort Cloud. The Oort Cloud is thought to be the source of long-period comets, which take more than 200 years to complete an orbit around the Sun. Unlike short-period comets from the Kuiper Belt, long-period comets have highly elliptical orbits and can take thousands or even millions of years to return to the inner solar system. Examples of famous long-period comets include Comet Hale-Bopp, which last appeared in 1997, and Comet Hyakutake, seen in 1996. These comets likely originated in the Oort Cloud and were dislodged by the gravitational influence of passing stars or molecular clouds, sending them hurtling toward the Sun. Formation of the Oort Cloud. The Oort Cloud is believed to have formed early in the history of the solar system, around 4.6 billion years ago. During the solar system's formation, icy planetesimals were scattered outward by the gravitational influence of the giant planets, Jupiter, Saturn, Uranus, and Neptune. Many of these objects were ejected far beyond the planets, forming the distant Oort Cloud. However, due to its vast distance, no direct observations of the Oort Cloud have been made. Its existence is inferred from the behavior and orbits of long-period comets. Both the Kuiper Belt and the Oort Cloud play crucial roles in the overall dynamics of the solar system. Their most visible impact is through cometary activity, but they also contribute to our understanding of the solar system's past and its possible future. Source of comets: short-period comets. Originating from the Kuiper Belt, these comets have relatively predictable orbits and are often influenced by the gravity of the outer planets. Long-period comets. Ejected from the Oort Cloud, these comets appear more erratically and are more difficult to predict due to their highly elliptical orbits and the influence of forces outside the solar system. Comets are significant because they provide insights into the early solar system's chemistry. Their icy compositions have remained relatively unchanged for billions of years, preserving the primordial materials from which the solar system formed. When comets come close to the sun, they release gases and dust, forming glowing comas and tails, which are spectacular sights and also valuable scientific opportunities to study their composition. Planetary migration and evolution. The interaction between the Kuiper Belt and the giant planets, particularly Neptune, may have been a key factor in shaping the solar system's current layout. A theory known as the Nice model suggests that the migration of the gas giants in the early solar system disturbed the Kuiper Belt, sending a wave of KBOs inward and leading to the late heavy bombardment of the inner planets. The Kuiper Belt may also hold clues to the mysterious Planet 9, a hypothetical large planet that could be lurking beyond Neptune, affecting the orbits of some KBOs. Galactic influences. Objects in the Oort Cloud are susceptible to gravitational disturbances from passing stars and even the galactic tides, the pull of the Milky Way galaxy itself. These interactions can dislodge objects from the Oort Cloud and send them toward the inner solar system. In rare cases, this could lead to catastrophic impacts on Earth or other planets, although such events are extremely infrequent. The Kuiper Belt and Oort Cloud, while still largely mysterious, represent critical frontiers in our understanding of the solar system. The Kuiper Belt is a nearby repository of icy bodies and dwarf planets, while the Oort Cloud extends into the farthest reaches of the Sun's influence, holding the most distant, icy remnants of the early solar system. Both regions are critical to understanding cometary behavior, the formation and migration of planets, and the history of our cosmic neighborhood. As technology improves and new missions, like NASA's New Horizons, venture further into the solar system, we will continue to uncover the secrets of these distant realms and their roles in shaping the solar system as we know it today.